Welcome to Engineering Studio with Dr. Muhammad Tahir. In this video, we are going to discuss about the design of staircase. We will learn how we can decide the size of different component of a stair. So before we move toward the design example, first we need to know about some important formulas. So the first one is the number of steps. So the number of steps in case of stair is equal to number of riser in the stair, and number of tread is equal to the number of riser minus 1, or the number of rise minus 1. And if we talk about the number of steps, so it will be equal to number of treads plus 1, or number of riser. So similarly, the number of steps required in any flight, or the number of steps required for the stair, is equal to the total height of the floor divided by the height of the rise. Similarly, number of steps available will be equal to number of treads available plus 1, and number of treads available is equal to actually length available for steps in each flight divided by width of tread. And finally, the number of steps required should be equal to number of steps available. So for proportioning of the stair, the number of steps required should be equal to the number of steps available. Okay, now let's see one design example, that how we can proportion a stair for the given staircase. So it is stated that design and proportion the stair for given staircase of a residential building. The width and length of staircase are 7 feet and 15 feet respectively. So this dimension is 7 feet and this dimension is 15 feet. The total height of the floor from the plinth level is 13 feet. So the total height covered by these stairs should be equal to 13 feet. Okay, so now in designing and proportioning of the stair, we need to decide about the width of landing. We need to decide about the width of flight or width of stair, and we also need to decide about the step size. What should be the rise and what should be the tread. So first we will decide about the width of the flight or width of stair and the width of this landing, this dimension. So assume the width of stair is equal to 3.5 feet. So as the overall width is, this width is 7 feet, so we can accommodate two flights of 3.5 feet. So the width of stair is 3.5 feet, and in that case we can have two flights of 3.5 feet. And assume the width of landing. So this width of landing, we can assume it equal to the width of this single flight or width of stairs, so it will also be 3.5 feet. So here in green, so it is written that the width of landing should be almost equal to the width of stair, or minimum 3 feet. So the minimum limit for this landing is 3 feet, and preferably it should be equal to or greater than the width of stair. So we will have two flights, one flight of 3.5 feet wide, so the total width is 7 feet, so we can have two flights. And the length available for steps in each flight, so this much length starting from here up to here, so this length is equal to the total length, this length, minus the length of the landing or the width of the landing. So it is 11.5 feet, which is equal to 138 inches. So here we have a note that calculate the available length for each flight separately and then calculate the number of steps available for each flight. So this is because we can have different length of the landing, different length of the flight. For example, our first flight can be of this much length and the second flight may end over here. So in that case we will have two landings but with the different length. So in that case we need to calculate the number of steps for flight 1 and for flight 2 separately, and for some time we have the stair like this. So in that case the length of the landing or the length of the flight can be different. So we need to consider this factor separately for both the flights or for all the available flights. We will calculate the available length for each flight and then we will calculate the number of steps available. Okay, after deciding the width of the stair and the width of landing and the number of flights, the next step is to decide the step size. And in case of step size, we need to decide the size of rise and the size of tread. So first of all, we can assume the values of the step size. So we have assumed the rise is equal to 6 inch and tread is equal to 12 inch for a residential buildings, because this is the ideal size in case of a residential building, and the limit can be 5 to 8 inch for rise, and for tread it can be 9 to 14 inch, but these two are the most preferable values. So after assuming the initial step size, now we need to calculate the number of steps required and number of steps available, and then we will compare these two. So the second step is calculate the number of steps required. So the number of steps required is equal to total height of the floor divided by rise. So the total height is 13 feet and multiplied by 12 to convert it into inches, divided by the height of the rise, and it will give us a value 26. So the number of steps required is 26. So it is the total number of steps required. So if this value is in fraction, so then we need to round this value, and preferable is to round this value up, round up this value. For example, if we get the answer 22.4, so it's better to round it to 23 instead of to 22, because the least value of rise is more preferable. So if we will round up this value, so it means the resulting rise will be lesser than our assumed value. Okay, so the third step is to check the number of steps available. We have calculated the number of steps required, so which is 26. Now we need to check the number of steps available. So for that, we will calculate the number of steps available in each flight, and then we will sum up those values. So the number of steps available in first flight, so it will be equal to length available in first flight for the steps divided by size of tread plus 1. So 138 inches is the length available for steps in first flight divided by the size of tread, which is 12 plus 1, so it gives the value 12.5. So now we need to round this value, and the preferable is to round down this value, because the higher value of tread is preferable. So once we round down this value, so we will get the higher value of the tread. So the number of steps available in one flight is 12. So the total number of steps available will be equal to 12 times 2, because we have two flights of the same length. So the total available steps are 24. Okay, the last step is to compare the number of steps required and the number of steps available. So the number of steps required are 26 and the number of steps available are 24. So these are not equal, so it is not okay. So now we need to revise the step size. So here are some notes. If the number of steps available are more than the number of steps required, so if the number of steps available are more than the number of steps required, so then it is good. So what treatment should be made, or how we can revise the step size? So in that case, either reduce the size of rise, or increase the size of tread, or increase the size of landing, or introduce some intermediate landing if possible. So firstly, we can reduce the size of rise, or we can increase the size of tread. The third option is to increase the size of landing, or the fourth option is to introduce intermediate landing, because this condition is preferable if the number of steps available are more than the number of steps required. And if the number of steps available are less than the number of steps required, so in that case, either we can increase the size of rise, or we can reduce the size of tread. So this is not a preferable option, but if the condition is so we can increase the size of rise, or we can reduce the size of tread within the allowable limits, or we can play with both. We can increase a little bit riser and we can reduce the size of tread. So we can play with these two to get the optimum value. So if we see in our case, the number of steps available are less than the number of steps required, so it means this second condition will prevail, and we have two options: either we can increase the size of rise or we can reduce the size of tread. So we will prefer to reduce the size of tread because here we have assumed a tread size of 12 inch and this is without nosing. And if we reduce it up to 1 inch, then we can again get the size of tread equal to 12 inches by providing nosing of 1 inch. So we can reduce the size of tread to some little value, some lesser value. So the second trial, so again we need to assume the new value of step size. So as I have told earlier that we will not play with the rise, we will only play with the tread. So we have kept the rise same 6 inches and we need to reassume the value for tread. So instead of assuming the value of tread for the second trial, we can calculate the exact required value of the tread. So how we can do that? We know that number of steps available should be equal to number of steps required. So if we compare these two values, we can get the required value of tread. So we know that for the rise of 6 inches, the step size required or the number of steps required is 26 for both the flights, and for single flight the number of steps will be 13. And if we replace this number of steps available with the number of steps required, 13, so in that case we can get the value of tread. So here we have written that 13, the number of steps required, is equal to, this is the number of steps available, the length available for the steps divided by the size of tread plus 1. So we have written this equation in terms of tread, and then finally after solving this equation we will get the value of tread, and it is 11.5 inches. So initially we assumed its value 12 inch and now its value comes out to be 11.5 inch. So now we can reduce the tread to 11.5 and recheck whether the number of steps required are equal to number of steps available. So from this equation we have got this new tread which is 11.5, and now our step is 6 inch by 11.5, and for 6 inch rise the number of steps required are again 26. It is the same as previous, and number of steps available now is equal to 138 divided by 11.5, the new size of tread, plus 1, and it is 13. And the total number of steps available are for both the flights, as both the flights have same length, so it is 26, 13 times 2. So now after calculating the steps available and steps required, so we can compare these two values. So number of steps required should be equal to number of steps available. So 26 is equal to 26. So it's okay. So hence we can say that this is our final step size. Rise is equal to 6 inch and tread is equal to 11.5. For this step size, this condition is satisfied. Okay, now we have some important notes. If you have rounded the value of number of steps required, then what to do? So as we have calculated the number of steps required, and in our case its value was 26, it is a whole number. But if it is a fraction value, for example 25.5, and we have rounded it to 26, so then what will happen? So in that case, if we have rounded up this value, so then check the difference in total height covered by the finally selected number of steps and the total height of the floor. So we need to find the difference, mean height covered by steps, finally selected step, minus the total height. We need to find this difference. For example, I call it as y. And then equally distribute this difference to each rise of the step. And then, for example, we have 26 steps, so we need to divide this y by 26, and we need to add or subtract this value to the rise respectively. For example, I have given one example over here. If the total height of the floor is 160 inches and the total height covered by the 26 steps of 6 inch rise. So this is our selected rise and the number of steps provided. And so the total height covered by these 26 steps, and with the rise of 6 inches it will be 156. Then the difference of 160 minus 56, the total height minus the height covered by the steps, so it will be equal to 4 inches. So if we provide the 26 steps of 6 inch rise, so then we will short of 4 inches. So we need to distribute this to each step equally. So the final value of rise in this case will be 6 inches, the initially provided, plus, because we are short of 4 inches, so in that case it will be plus 4 divided by 26. So we have distributed this 4 inches to all the steps equally. So 4 divided by 26. So our final step will become 6.15 inch. So similar treatment is also required for the tread if the value of steps available is rounded in any flight. So if we have rounded the number of steps available in any flight while calculating the number of steps while deciding the size of tread and rise, so in that case again we need the similar treatment as we have done in case of riser. So this is very important. Otherwise you will have the final step of different size from the others. For example, here we will have the final step equal to 6 inch plus 4 inch, mean the final step will be of 10 inches, or we need to provide some extra step, one extra step of 4 inch. So to avoid this, we need to distribute this 4 inches to all the 26 steps. Okay, the final output will be reported like this. The rise is 6 inches, tread is 11.5, number of flights are 2, number of steps in each flight is 13, and the width of stair is 3.5 feet, and width of landing is 3.5 feet. And then we can draw it like this. So we have 2 landings, and we will show the number of steps over here. I mean the 13 steps in each. So here as well 13 steps. This height will be this width will be 3.5. So this landing width will also be 3.5, and the size of tread will be 11.5 inches. So in this way we will report our final output of the stair design.